This is my budget constraint, right? Again, my opportunity set, the set of all bundles I can consume, lower left corner 0, 0, 8, 0, and 0, 8. That's my opportunity set. The points where I'm spending all of my money are the points along that black frontier here, the budget constraint. Now, what do indifference curves for perfect substitutes look like? Are they bent? Are they L-shaped? Anybody? Say it loud, yes. Slope of -1, right? You've gone ahead already and said, Max, you said they're perfect substitutes to you. They're both in 16-ounce bottles, so they're a straight line with slope of -1. What's your name? Elizabeth. Excellent answer to that question. Thank you for paying attention. So the point here is my indifference curves are going to be straight lines with slope -1. So let me draw a couple. We will get all fancy. Budget constraints in black, indifference curves in red. So I'm going to draw you a couple of my indifference curves here. Here's the first one. How about another one? Okay, this here I'm going to call I1. This one here I'm going to call I2. Can I afford I1? Yeah, how about I2? Yeah. Okay, I'm going to draw you another one. So it's going to be a little bit challenging. I don't know if this thing will cooperate. Ooh, wow. Okay, here's another one, the 8, 8, 1. It's right on top of the budget constraint, okay? What does this mean, Max? Can I get on indifference curves that are even higher than this indifference curve I3 here? No, right? I can't afford them. They're beyond my budget constraints. But is there one specific bundle here that makes me happier on that red line than any of the other bundles? I am indifferent between all the bundles on the red line, and I can afford all of those bundles. Right? So what does this mean? Imagine you're in a supermarket. Bottled water goes on sale, so Arrowhead and Dasani are on sale, right? They're $1 each. Everything else is $2 each. And there's a big bucket of these bottles, and they're perfectly mixed, right? Arrowhead and Dasani bottles. Are you going to go in and just pick out the Dasani ones? No. You're just going to go in there, and you're going to throw 8 bottles of bottled water into your shopping cart because you really don't care. They're perfect substitutes for you. You're just as happy with 8 of one, 0 of the other, 0 of one, 8 of the other, or any linear combination, 4, 4, 5, 3, 6, 2, 7, 1, and so on, right? So you're indifferent between any of these bundles, right? That's pretty neat. So Max, I'm a little bit confused. You told me with perfect substitutes, I would get a corner solution where I'm just consuming some of one good and none of the other, right? This is what you advertised, and now you're giving me some lame picture here where I could have both corner solutions, 0, 8, 8, 0, or anything in between. Well, this is a special case. Let me give you another scenario here. What about, ooh. Okay, I have an idea how we're going to do this. Okay, you may need a blank sheet of paper. I'm sorry, I'm getting better at this stuff. Okay, so let's clear this out. Don't give me the ha. It's not that bad. Okay, so let's double the price of Arrowhead. Okay, price of Arrowhead is $2. Price of Dasani is $1. Now, has my budget constraint changed? Yeah, right? So budget constraint's black. So I have $8 of income. Arrowhead is $2 a bottle. If I spend all my money on Arrowhead, I can afford 4 bottles. If I spend all my money on Dasani, I can afford 8 bottles. So now my budget constraint looks as follows. Why are you not drawing? Here we go. That looks like our new budget constraint. We'll talk about rotation in a second, but what happened, right? Before it was 8, 8. Now it's 4, 8. Well, Arrowhead became more expensive. My income didn't change. Price of Dasani didn't change. But since one of the goods now became more expensive, my opportunity set shrunk, right? The triangle of possible bundles that before was 0, 8, 0, 0, and 8, 0 is now 0, 8, 0, 0, and 4, 0, right? It shrunk. What happened to my marginal rate of transformation? Did it change? Did the price ratio change? Yes, right? If either the numerator or the denominator changed, the fraction changes. Of course it changed. My marginal rate of transformation changed, and now, all of a sudden, Arrowhead is more expensive than Dasani. Okay, what's the optimal consumption bundle? Let me give you one candidate. That one candidate looks as such. All right, my preferences, of course, didn't change. They're still perfect substitutes to me. It's my indifference curve, 4, 4. I'm going to call this A Stanford. Okay? The Stanford kids are going crazy. They're like, yeah, Arrowhead, $2 a bottle. I'm consuming all Arrowhead. Okay, do you think this is as well off as the student can make themselves by consuming 4, 0? Can you make yourself better off? Come on, you Berkeley students. Of course you can, right? Can you get on a higher indifference curve that still shares a point with the budget constraint? Let me give you a candidate. If you have any family at Stanford, I apologize. But you got to pick on somebody, and they can take it. Okay. Here's another indifference curve. Okay, let's call this one I1, and this one here I2. Can I afford this consumption bundle up here? Can I afford that? Yeah, it's on the budget constraint. Does it make me happier than 4, 0? Yes. Right? Can I get on a higher indifference curve than I2 and still afford a bundle? No, right? So I2 is the highest indifference curve you can get on and still have a point on the budget constraint. Are you consuming some of both goods at that equilibrium? No, you're consuming just Dasani, no Arrowhead. And this is called a corner solution. Is the slope of the budget constraint, the slope of the black line, the same as the slope of the indifference curve? No, indifference curve is flatter than the budget constraint. So the marginal rate of substitution, the slope of the indifference curve, is not the same as the marginal rate of transformation, which is the slope of the budget constraint. Right? So at this corner solution here, the two are different. Right? So at corner solutions, the rate at which I'm willing to trade one good for another doesn't have to be equal to the rate at which the market lets me trade off between the two goods. Now, what you're saying, I think, or what you should be saying, is the following. Max, we just spent 10 minutes of a lecture that I'm spending like $250 of lifetime income on. And you're telling me if I have $10, I buy all of the cheapest good if I don't care which one I get, right? That's exactly what I just told you. But the beauty of that is, this is a model and a framework that comes up with predictions that are exactly consistent with the type of behavior that people display when they make choices here. So it's flexible enough to allow me, if I have goods as imperfect substitutes, to come up with optimal consumption bundles where you consume positive amounts of all goods, but it also allows for settings where you consume all of one good and none of the other, right? In reality, there's a large number of goods we don't consume any of. One of my former grad students spent 18 months in Niger doing field work. So she drank a lot of millet beer because that was the only thing there was, right? I consume 0 units of millet beer for multiple reasons. You can't get it here, and B, I don't know how good it is, so I don't consume it, right? I don't consume any Porsches. I don't consume any Nissans. I don't consume any BMWs. There are goods all around that we consume 0 units of, and our model has to be flexible enough to account for it. Okay, well, Max, that's pretty cool. But what you're telling me here is depending on the prices, right, which good is cheaper, I consume all of one of the goods. And maybe, if the prices are lined up exactly such that the marginal rate of substitution and marginal rate of transformation is exactly the same, I'm indifferent between any linear combination of the two. Is there another setting where I have a certain type of preferences where I can get to an interior solution if prices change over a certain range, but I have a corner solution if prices are in a different range? I didn't explain this well, so let me show you what I mean by that bizarre setup here. So there's something called quasi-linear preferences. Fiona is raising one eyebrow and said, you didn't just pull out quasi-linear preferences. Those were a nightmare in grad school, and you're going to make 200 undergrads do this? That's sort of what you were thinking. Yeah, exactly. I agree with you. You can handle it. 12 years of Berkeley undergrads were able to handle this, or a subset of the 12 years of Berkeley undergrads I thought were able to handle this. But I just want to show off how flexible this model is. Okay, quasi-linear preferences are sort of like preferences if one parent is imperfect substitutes preferences, and the other parent is perfect substitutes preferences, and the two got together and had a kid, okay? You get quasi-linear preferences. They're quasi-linear. All right, so I call them Max's weird preferences over Dasani bottled water and champagne. Okay, so what's the biggest problem with Dasani water and champagne? Champagne's really expensive, okay? I made it relatively cheap in my example here, but let's say I have $8 to spend, okay? I should stop saying okay all the time. It's really annoying, but we all have our flaws. So let's call this here Dasani, and this here champagne. If I spend all my money on champagne, how many units can I afford? 1. What did we say? The budget constraint's black, right? Yeah. So 1 unit of champagne. If I spend all my money on Dasani, how many units can I afford? 8. So that's what my budget constraint looks like. Credit card, where did you go? This is worrisome for multiple reasons. Let's pull out second credit card. Always good. Okay. Let's draw this budget constraint. Also, holding your magnetic strips up to computers probably is really smart. That's my budget constraint, right? If I have $8, Dasani is $1, champagne is $8. How much champagne do you think I consume on a daily basis? Yeah, I'm not going to let you find the answer to that. But let's say this made-up Max here consumes 0 champagne and consumes all water. Why is that? Well, Max thinks champagne is just really way too expensive relative to water, and his preferences are quasi-linear. All right. You ready for some quasi-linear preferences? I don't know if I am. I'm nervous. I'm shaking. Can you tell? All right, here we go. Wow, that looks pretty good. Actually, that looks terrible. Hold on. Let's try that again. Better? Yeah, better. So there's sort of like imperfect substitute preferences that stop at the x-axis, okay? Something like this. They look a little bit like gills on a shark. So what's the highest indifference curve I can get on? Well, take any straight line from the origin, draw it anywhere. So the higher indifference curves are the ones to the right here. So this here is I1, I2, I3, I4, I5. What's the highest indifference curve I can get on? It's I5, right? So the consumption bundle with my quasi-linear preferences here that I've drawn, that I'm consuming, given that this is what the relative prices of Dasani and champagne are, and that's what my income is, I'm consuming all bottled water, 0 champagne. Do I never consume champagne? Well, you don't know that, but I do like the occasional glass of champagne. It's delicious. It's a real sort of celebratory type beverage for me. But at $8 a glass, I'm not doing it. Well, what happens around the holidays? Right? Well, okay, that could be one argument. The other thing is what happens. The price of champagne goes way down, right? But the preferences could change, but that's more complicated than we want to get into. So it's a good answer, but can I table that until we get to sort of advertising? All right. So let's say my preferences stay constant, but the price of champagne changes. So if you go to Bevmo around any holiday, champagne always seems to be on sale. Trader Joe's too. You can buy champagne for $6, headache in a bottle. But the point here is price of champagne all of a sudden goes down to $1. Do you think Max is going to consume some champagne? Probably. You think he's still going to drink some bottled water? Yeah, it's better, right? I shouldn't drink champagne before I walk into this distinguished room. So the point here is, let's look at the budget constraint. Has it changed? Has my budget? Yeah, it has, right? The prices have changed. So now, budget constraint, black. If I spend all my money on Dasani, I can afford 8 units of Dasani. If I spend all my money on champagne, I can afford 8 units of champagne. Now I'm using my global traveler card to draw lines. This is not good. Okay. That's what my budget constraint looks like. It's supposed to be a straight line, but you see what I'm saying? Let me show you what these quasi-linear preferences look like now. I'm going to draw them by hand. They're supposed to be the same as before, but I'm just going to redraw them. Oh, that's terrible. Hold on, let me try that one again. There we go. You sort of see my point, I hope. No, that's terrible. One more time. I'll bring you more chocolate next time. This is really hard. On the blackboard, this is almost impossible, but on this thing, okay. Comes down. Bingo. Okay. What do I have here, right? I have these shark-like quasi-linear preferences that, of course, stop at the x-axis here, right? Negative consumption of champagne doesn't make any sense. But what do I have on this highest indifference curve all of a sudden? Does that look like a tangency, right? So if we zoomed in, Max is just showing off now. Here we go. See this thing? The indifference curve comes in, is tangent right here, and then does its sort of quasi-linear thing and stops at the x-axis right here. So what happens now? Am I consuming just Dasani? No. Am I consuming just champagne? No. What I'm consuming is some of both goods, right? Now I'm in a price range. If all of a sudden the prices of Dasani relative to champagne change a little bit, I'll trade off some Dasani for some more champagne in either direction, depending on how the relative prices change. But I'm at an interior solution, right? So these quasi-linear preferences have the nice property that they allow for models that if the prices of a certain good are really, really expensive, you consume none of it, right? But as prices come down, all of a sudden people consume positive quantities of these goods. Solar panels are a good example of this, right? Prices of solar panels have come down tremendously. They used to be sort of a thing wealthy people that wanted to display that they're green put on their roofs. Now it's something they're in a price range where a lot of people actually think they're at a price point where consuming a positive amount of solar panels makes sense because their relative price relative to other sources of energy has come down quite a bit. We will talk about solar panels quite a bit because the price that consumers see and the price that society pays for the solar panels on your roof are two totally different things, and we will talk about what this means for social welfare. That'll be quite interesting. So please do not panic about quasi-linear preferences. I just wanted to show them to you. They're in your book. They're a pretty neat thing to keep in the back of your head and to remember that they exist. Okay, we're about one slide away from deriving one of the two most important things in economics, the demand curve. But before I do that, I want to just talk to you briefly about how to move the budget constraint around. Right? The budget constraint moves. The budget constraint is fully determined by three things. It's determined by income, the price of the good on the x-axis, and the price of the good on the y-axis, right? Those are the three numbers that fully determine your budget constraint. So what changes the budget constraint is if any of those three things or multiple of those three things change. So let's do it really easily in the way that what we're first going to do is we're going to assume a level of income, we're going to assume a price of Reese's, a price of Hershey's, and then we're going to let the price of Hershey's change. Then on the second graph here, what we're going to do is we're going to go back, assume an income, assume a price of Hershey's, price of Reese's, and then let income change and see what happens to the budget constraint. We've already done this a little bit, but I just want to make sure we get this exactly right, because if you don't understand this part, we're never going to get anywhere. Okay. Pen. There we go. All right. I'm going to assume that income is $8, that price of Reese's is $1, and the price of Hershey's is also $1. I'm going to draw that budget constraint, and then I'm going to change the price of Hershey's. So if income is $8, both of the goods are $1 each. The budget constraint goes from 0.8 to 8.0, right? And again, Reese's y-axis, Hershey's on the x-axis. Bless you. Here's my budget constraint. Let's try that again. That's better. Okay, this is my budget constraint. Again, I could figure this out from these two endpoints. Now what I'm going to say is Hershey's go off sale, and I'm going to say that PH prime is now $2. So the price of Hershey's doubles, income stays the same, and the price of Reese's stays the same. So if I spend all my money on Reese's, how many Reese's can I buy? 8, right? Now if I spend all my money on Hershey's, how many Hershey's can I buy? 4, right? So this point here doesn't change, but what changes is the amount of Hershey's I can buy. So my budget constraint is now steeper, or as I like to say, it rotated in. Right, so the slope of the budget constraint has changed. My marginal rate of transformation used to be 1 for 1. Now I have to give up 2 Reese's for each Hershey's, right? So my marginal rate of transformation has changed by a factor of 2. So if a single price changes, the budget constraint rotates with the hinge staying constant of the good whose price doesn't change. So if the price of Reese's were to change, the line would be anchored here, and if the price of Reese's changed to $2, it would rotate this way. So that's a rotation of the budget constraint where now the marginal rate of transformation changes. The other thing we could, of course, change is income. So start with a scenario here where income is 4, and price of Reese's is equal to the price of Hershey's is equal to $1. So if I spend all my income on Reese's, I can afford 4. If I spend all my income on Hershey's, I can also afford 4. So my initial budget constraint looks like this, 4, 4. Now Grandma, love Grandma, sends you an extra $4. That's the only thing that changes. All right? Grandma sends you an extra $4. What happens to your budget constraint? Well, now if you spend your $8 on Hershey's, you can afford 8. If you spend your $8 on Reese's, you can afford 8. And your budget constraint looks like this. Okay? So an income change, especially an income increase, shifts the budget constraint out parallel. What happened to my marginal rate of transformation? Nothing. Same thing, right? I just have more income, but the relative prices didn't change. Question or stretch? All right. So let me walk you through that one, right? So let's say you have $8, okay? Reese's are $1 each. How many Reese's can you buy? Hershey's are $1 each. How many Hershey's can you buy? Right? So those are those 2 points. That's my new budget constraint. If I did the old example, where if I had $4 and the prices are the same, right, I can only afford 4 Reese's and 4 Hershey's, right? So it's just the amount of money in your pocket that changes, but the prices advertised at Walgreens don't change. So you started with $4, and then you get 4 more dollars, and you're now at 8. So your budget changes from 4 to 8. But again, this stuff, these models, while they look all fancy and they're digital now, really, if I double the amount of money in your pocket and you go to the store, what ratio of good or what multiple of the goods you could afford previously can you afford now? Double, right? The prices didn't change. If all of a sudden the price of Hershey's doubles and your income is constant, you can afford half the number of Hershey's you could before, right? So the point I'm trying to make here is one, if your price changes, if a single price changes, your marginal rate of transformation, the exchange rate from Reese's to Hershey's changes. If income changes, the marginal rate of transformation doesn't change, right? If price increases, your opportunity set shrinks from this big triangle to this smaller triangle, right? So after the price increase, you can afford all of these bundles, and